Hello everybody, my name is Ray Kruse, Food Systems Program Coordinator and Master Gardener Coordinator right here at the ISU Extension Outreach Office in Dubuque County. And welcome to this third part in this three-part Gardening Take-Home Kit series. And what we're working on today is backyard soils. Now before we dig into this kit, I would like to thank our funding partners. And if you're in Dubuque County, you can thank your ISU Extension Outreach Office right here in Dubuque County. We would also like to thank our corresponding partners for helping us to bring this kit to you, such as local libraries and nonprofits. If you're outside of Dubuque County, we'd like to thank our other cooperating partners for bringing this kit to you as well, and you'll know based on how this kit is presented to you. So, with this kit, what we have done is we have combined two activities. First, we're going to talk about soil testing and how to take an appropriate soil test and when you should take a soil test. The next activity is an illustration of what sand silting clay is and how they make up your soil. So have fun and enjoy. The first thing we're going to talk about is soil testing. Now you might be wondering, why would I take a soil test? Well, the answer is simple. We can't really just look at a piece of soil and have it tell us in English, Ray, my pH is off. Or, Ray, I need potassium, your plants are starving. It doesn't work like that. I wish it did, because it'd be a lot easier. But the only other way we're going to get that information out of the soil is by observing sick plants that are showing nutrient deficiencies or with a good old-fashioned soil test. Now you might be like, I'm going to go take this soil test, submit it to a lab, and they're going to send me back information. But what really am I looking for from that information? Well, the first thing for most beginning gardeners is your pH. Now, most of our garden soil, we're going to want a pH between 6 and 7. There's the occasional exception where we're not going to want it in that range, but for the most part, that's where we're going to need it to be. Especially if we're starting a new garden, it's important to know that your pH is within the right range if you're spending a lot of money. Now, this test will also give you feedback or information on the organic matter, which is used as an indication for nitrogen, and phosphorus, and potassium. And most of our soils in Dubuque County test sufficient for those nutrient levels. So don't be surprised if your test comes back and only needs a minimal amount of amendment, because for the most part, most gardens test within that range. So with that, this next portion of this video, you'll see how to take an appropriate soil sample for submission to a laboratory. Have fun. Hello everybody, my name is Ray Kruse, Food Systems Program Coordinator and Master Gardener Coordinator with the ISU Extension Outreach Office Dubuque County, and today we are talking about soil sampling. It's October 2nd, 2020, and we just had our first frost last night. And you might be thinking, shouldn't we be wrapping things up for the year instead of soil sampling? But you know the optimal time to send a soil sample to the laboratory for a garden is anytime the soil can be worked. It's nice to send it in the fall because that way you have all winter to calculate your amendments and source those amendments so that you can hit the ground running next spring. Now, when taking a soil sample, all you really need is a pail and a garden trowel. You don't really need a soil probe because you can receive great results using these two things. One of the primary things that a homeowner should consider when sending a soil sample to the laboratory is what soils to include in that final sample. And we're going to talk about that here. We are on site with this house, and what we're going to do is we're going to talk about this perennial bed that this homeowner is going to want to put around the entire house. And that's marked off here by this blue rope. And before identifying where we're putting that perennial bed, we called 811 to identify our utilities. Now, this homeowner here is looking to put one entire perennial bed around the entire house. So we're going to submit one soil sample because this will eventually be backfilled with all the same soil. And it's best to sample or test the final soil that's going to be here, but for the filming location, this is what we had to work with. But what we'll do is submit one sample for around the entire house. An example where we're going to submit two samples is if we had a vegetable garden that existed out on the lawn, where we fertilized annually, tilled annually, and maybe took vegetables and fruits off. And that's managed a little differently than this perennial bed here where we're not really doing those practices. So that's an example where we submit one sample for the perennial bed and one sample for the vegetable garden. Now, moving on to actually taking our soil sample. A soil sample consists of many little subsamples. And those subsamples, I'm going to show you exactly how to do that right here. We'll put our pail up here. And what we're going to do is we're going to go to our bed that we're going to put our plants into, or that we already have plants in, and we're going to dig a hole down in the soil. And what we're going to do is we're going to dig down to 6 inches for beds and areas that are typically tilled. This would be perennial gardens, vegetable beds, things like that, typically we sample down to 6 inches. If we had an established lawn, we'd only do 3 inches, or if we were planting really large shrubs or trees, we would go down to 1 foot. But in this instance, we're only going down to 6 inches, and I have that marked here on my trowel with this black marker. But what we're going to do is we're going to dig that hole down to the 6-inch sampling depth. And then what we're going to do is on the side of the hole, we're going to cut a slice off the side of that hole. So I'm going to go 1 inch back from the side of the hole, and I'm going to slice straight down. And we're going to take out that slice. And what we're going to do is we're going to go over to our pail here and try and take out any plant debris and things like that. And we're just going to dump our soil right in there. And there we have what we call a sub-sample. Now, our full sample that we're going to send to the laboratory is going to consist of 15 of these sub-samples that we're going to do all the way around the house. And you're going to sort out rocks and grass and things like that before putting it in here. So I'll have you join me right back after we get those 15 sub-samples taken. Now, you probably got to sub-sample 8 or 10 and we're like, gosh, this is taking a lot of time, you know, it's a lot of work. Do we really need to get to all 15 sub-samples? Well, the answer is yes, if you want a very good representation of the soils that are in your garden. And the reason why is demonstrated right here. I had our landscape contractor bring up some soil so that we could see what's going on. And this is the topsoil that's going to backfill our perennial beds. And just within this black topsoil that we have here, we have a lot of good, nice, rich, dark topsoil. But occasionally we have these pockets of lighter orange material. And this might test just a little bit differently than the rest of our actual topsoil that is representing our perennial bed. And so if we happen to hit this underneath of one of our subsamples that we're taking out in the garden, we might not know it. It might have a bad sample. So we might have 1 in 8 be bad instead of 1 in 15, which further dilutes a bad sample if we happen to have one. So I hope you learned a little bit as to why we're actually aiming for 15 subsamples. We have taken our 15 subsamples from all the way around the house. And now that we've got our subsamples taken, we have ourselves an actual soil sample. Now that we've got them all together, what we're going to do is we're going to break apart our soils so that all the pieces in here are less than the size of quarters. And then once we get done doing that, what we're going to do is we're going to mix our soil up very, very well. And we'll do this for about a minute. And to avoid boring you, I've already mixed this up pretty well already. So what we're going to do here is we are going to put our soil in our test baggie. And that is just simply a quart Ziploc baggie here. We're going to pour it in there. And you might realize we left a lot of soil left back in the bucket that we just took out of the ground. But the important thing is that we have a little bit of all 15 subsamples in this actual soil sample to be sent to the laboratory. Now, laboratories most often will want you to have the bag labeled as well as some supporting information or paperwork. And that paperwork tells the laboratory what tests you want done. Most gardeners have pH, organic matter, phosphorus, and potassium done on their soils to make general decisions. If you're in Iowa, all extension offices have access to the soil testing kit generated by the ISU Extension Outreach Office of Dubuque County. So seek out your local extension office if you are in Iowa to see if this resource is available to you. Now that you have your soil sample ready to be sent off to the laboratory, you will hopefully get some supporting information back to help you make good gardening decisions. This is Ray Kruse, Food Systems Program Coordinator and Master Gardener Coordinator with the ISU Extension Outreach Office of Dubuque County. Happy growing, everybody. The first part of this activity, we'd focus on soil testing, which measures more of the nutritional aspect of our soils. Now we're going to focus on more of the physical properties that make up our soils. We're going to first turn to our backyard soils kit here, and I'm going to talk about each one of the benefits and detriments that these parts that we're going to look at here in the kit brings to our soil. The first thing we're going to pull out here is our sand baggie. And I encourage you to open the baggie and give it a feel and see what you think. And inside here isn't anything that you probably haven't seen before. It's just plain old beach sand. But if you roll the individual pieces of sand around in your fingers, think about what that might bring as an advantage to our soil. It's actually aeration. It provides the ability for our soils to be aerated so that our roots can grow better. However, it does a poor job of holding nutrients, and it does a poor job of holding water, which is why a lot of our gardens that are rich in sand have nutrient problems and also have problems with water, and we need to irrigate them more often. Now, the next thing we're going to look at is our silt in the bag. And I have this represented here with baking soda. I don't really actually have a very good representation of silt itself in the form of soil, so this is the next best thing that I could find that would represent that portion. And if you feel the individual baking soda grains in your fingers, you can't really feel them that well, but then if you also try and blow on them, they're kind of a little dusty. And that's what silt is kind of like. It's in between the clay, which we're going to look at, and the sand that we were just at. And the benefits that this brings to our soil is water holding capacity for our plants so that they can take that water from the soil and use it for their benefit. However, it does a poor job of holding nutrients and does a poor job of aerating our soil like the sand does. The next thing we're going to look at is our clay portion of the soil. And if we go ahead and give that a feel and take that out and smush it between our fingers and we try and feel the individual grains of clay there, probably never going to feel them because they're just so small. And even if we were to take this and further dilute it in water, we're never really going to feel them individual pieces of clay in there just because they're so small. The pieces of clay are really microscopic. Now, the benefit that this clay brings to our soil is the nutrient holding capacity. And when we were testing our soil in the first part of this activity, we're primarily testing the nutrients held in the clay. Now, what this doesn't bring to our soils in terms of a disadvantage is it doesn't help our soils with aeration and doesn't help our soils with storing water. And now you might be like, now Rick, I've got a garden that's rich in clay and it is terribly wet and it takes forever to dry out. What do you mean it doesn't hold water for my plants? Well, clay is a little different from silt. So silt holds water too, but it holds available water. And clay, when it holds water, it grabs onto that water and doesn't really like to share it with our plants, which is why clay soils take so long to dry out. And sometimes our plants can almost look, almost wilted in a soil that is sometimes still looking wet when we dig into it when it's primarily clay, because the clays don't really like to share that water that well. But it does a very good job of holding nutrients. And the silt, on the other hand, does a very good job of holding water and shares it with our plants. There's one last thing we're going to look at here in the bag, and that is this individual stick that you may have thought was an accident, but actually is a representation of what we call organic matter. And you might be familiar with composting sticks and twigs and leaves and grass clippings down into compost, which is added to soil in the form of organic matter. And that provides many benefits to our soil. Provides a lot of nutrition, and it also is a big measure of nitrogen in our soil. So I have this here. It's not really that easy to see it without seeing the real thing, which is why the stick is in here representing this. Now, in the next step of this activity, I'm going to show you how you can see each one of these individual portions of the soil that we just talked about in your own soil at home. Welcome back. We're going to focus on an activity to help you see sand, silt, and clay in your own garden soils at home. Now, what we've done first is, from our first activity when we took our soil sample, I kept back some of the soil that we didn't send to the laboratory. And I dried it out on a piece of paper and sorted out anything larger than a pencil eraser and kept everything smaller. Our next step that we're going to do is we're going to grab our mason jar from the inside of our kit, and we're going to dump that mason jar's contents, which is super washing soda. We're going to dump that on the red piece of paper that you have included in your kit. After that, what we're going to do is we're going to measure out 4 ounces by volume of soil that we have dried out and crumpled up. And you'll see that mark here on the side of the jar. The individual 4-ounce mark isn't there doesn't say 4 on the side of the jar, but it'll be between the 2-ounce and the 6-ounce mark. So once we've measured out those 4 ounces by volume, we'll dump it back out on the piece of paper. You can use your directions sheet that was sent with this activity. And then what we'll do is we'll dump back in our super washing soda here. And then what we're adding the super washing soda for is if we remember in the first part of our activity talking about the clays really like to stick together. And what this super washing soda does is it breaks that apart so that we can see them better at the end of this activity. Now what we're going to do is we're going to take some just plain old tap water at room temperature, and we're going to fill this jar about half full. Once we get that in there, we're going to cap the jar here, and we're going to shake this until all of the contents have dissolved. So I'll have you join me right back here once we've accomplished that. It's been about a minute and a half since we have added our superwashing soda, and we've now dissolved the contents. What we're going to do now is we're going to take the lid off, and we're going to add back our measured soil volume here. I'm going to add that back into the jar, and then we're going to add just enough water to reach the large glass rim or band at the base of where the lid screws on. So you'll see a line on here that says freezing mark, and we'll go to the large glass band right there is where we'll add water to. And then once we've accomplished that, we're going to cap our jar once again here, and we're going to shake our soils. And we're going to do this for 2 minutes today. And then we're going to do this activity or shake this for 1 time a day for 1 minute for the next 7 days. And I'll have you join me right back here after we've accomplished that task. We have reached our 7th day of shaking for 1 minute. Now what we're going to do is we're going to leave our jar set for 48 hours, and I'll have you join me right back here with some results. Here we are back here with some jars that I'm going to show you hopefully what you will see in time as you shake your jar at home. This is a representation of what you'll see after your initial combination of ingredients here. And then in time what you'll see is maybe your water turn a little bit darker, but hopefully if you have a clay layer, you'll see a clay layer start to form at the top of your soil in there. And at the end of your 7 days of shaking, if you have lots of clay and lots of silt in your sample, you'll see them kind of move into suspension, and they might almost resist coming out of suspension. And like I said, this is 48 hours after the final shaking, and we are just seeing a clay line here. We could see it after 24 hours in some bright sunshine, but if we wait 48, we can see a little bit better what's going on here. And we can see here, and actually I had a laboratory confirm this, that we have a small amount of sand in here. We have 16% sand, 58% silt, and 26% clay. And so that's what we're seeing with this sample here. And our superwashing soda dispersed those clay particles so that we can better see them sit at the top, as opposed to what we were seeing over here where they weren't quite as mixed together or dispersed as well. Now, we're going to contrast this with another soil that's kind of a little bit on the flip side, and it's more sandy. And here we can see a lot more sand here at the bottom. We can see just a little bit of silt and a little bit of clay. And with this soil here, you might also be wondering, well, between both of these soils, actually, you might be wondering, where did our organic matter go? Well, our organic matter is either in the water suspension left in the jar or tied up in our clays, and it might be a little bit tied up in our cells, but mainly in the clays and in the water. So that's where our organic matter has gone. Now, you should be able to see at home with your soils a little bit and match this up a little bit with what you're seeing there, and also match that up with the individual little baggies of soil particles that I've given you, whether it's sand, silt, and clay. You can see that through the side of the jar there. Now, I will also say too that I've had personal experience with these two soils here, and this one here, being it is more silty and more clayey and doesn't have much sand, I will tell you that it is very difficult to work in the spring, and it takes a long time to dry out. However, it stores a lot of water for me. I rarely have to water the garden, and I also rarely have to worry about nutrients because I just have so much stored in that soil. However, with this sandy soil here, this is in a cornfield that I help manage, and this is the first field I'm able to go out into in the spring and till. However, with the lack of clays and lack of silt, it's also the first field to dry up in the summertime, and it's also the corn that sits on top of this ground here is usually really spindly and doesn't produce the best kind of corn for us. So hopefully you've learned a little bit with this activity as to what's going on with your soil, so that you can kind of see a little bit as to what the sand, silt, and clay ratios are for you. I'll have you join me right back here for the wrap-up. At the conclusion of this kit, I hope you've learned a little bit about the soils in your own garden, whether it's about the nutrients you might have out there with your own soil test that you can send to a laboratory, or by observing your sand, silt, and clay fall out of suspension in a jar in your own home. If you ever have any questions about the soils at your garden, feel free to call us right here at the ICU Extension Outreach Office of Dubuque County. I'm Ray Kruse, Food Systems Program Coordinator and Master Gardener Coordinator. Happy growing, everybody!